Hello, I'm Dr. N.B. Hulle. In this video, we will try to understand the problems on the transient response of the RC series circuit. To begin with the first problem, here the statement is for the circuit shown below, switch is kept open for a long time. Switch is closed at t is equal to 0. Then find the following. First is expression for voltage Vc of t for t greater than 0. Value of the voltage Vc of t at t is equal to 10 millisecond. Value of the voltage Vc of t at t is equal to tau, the time at which voltage Vc of t is 10 volt, and finally the expression for Ic of t and Vr of t for t greater than 0. In this case, a switch is kept open for a long time. This point itself indicates the circuit was in the steady state before switching. That is, this voltage across capacitor will be the maximum value, or this capacitor acts as an open circuit. We will analyze the circuit into two parts, that is circuit for t less than 0. For the t less than 0, the switch is open and the steady state was reached. That's why here I have shown the main circuit here. This capacitor acts as an open circuit because in the steady state this capacitor acts as an open circuit. And in this case, this Vc of t is equal to, or Vc of 0 minus is equal to Vc of 0 plus, that is voltage across capacitor before switching or after switching, which is equal to 0 volt, because this switch is open, that's why voltage across this capacitor will be 0. The second part, the circuit for t greater than 0. This is the source driven RC series circuit with 0 initial condition. In that particular case, we have this source as it is, this 8 ohm resistance, and this is the capacitor, and here this switch is closed at t is equal to 0, and we are planning, or we are interested in finding the transient response of the RC series circuit. To begin with the first point, we are interested in the calculation of the expression of voltage Vc of t for t greater than 0, and this is the case of source driven RC series circuit with 0 initial condition. And in this case, the expression for the voltage across capacitor is Vc of t is equal to V into 1 minus e raised to power of minus t by tau, where V is the voltage applied to the circuit after switching. Now here we will find out the value of this V and we will find out the value of the tau, and we are in a position to find the expression for voltage across capacitor. The V is the 12 volt and the tau is the time constant, which is Rc, and its value is R is the 8 ohm, C is the 2 millifarad, that is 2 into 10 to the power of minus 3, which is equal to 16 into 10 to the power of minus 3 second. Therefore, the expression for voltage across capacitor, that is Vc of t, is equal to 12 in bracket 1 minus e raised to the power of minus t by 16 into 10 to the power of minus 3, which is nothing but the tau. If we are plotting the graph, or graphical representation of this equation is something like this. At t is equal to 0, we have the 0 volt, and at the t is equal to infinity, we have the maximum voltage is available across the capacitor. Similarly, we are interested in the calculation of voltage Vc of t at t is equal to 10 millisecond. Vc of t is equal to, basic expression is the same, that is 12 in bracket 1 minus e raised to the power of minus t by 16 into 10 to the power of minus 3, and in this case we will put the value of the t as a 10 millisecond, which is here, that is minus 10 into 10 to the power of minus 3 divided by that value, and if we are finding the value of this expression, that is Vc of t is 5.57 volt, is the voltage across capacitor at t is equal to 10 millisecond. Third point in this particular case is value of the voltage Vc of t at t is equal to tau. Here in this case, the basic expression is Vc of t is equal to 12 into 1 minus e raised to the power of minus t by tau, and we will substitute the value of the t as tau, which is 16 into 10 to the power of minus 3. And if we are finding the value of this expression, we will get its value as 7.58 volt. The fourth point in which we are interested is the time at which the voltage across capacitor is the 10 volt. Vc of t is equal to 12 in bracket 1 minus e raised to the power of minus t by tau. When this Vc of t is 10 volt, we are interested in this particular time. Now we will substitute the value of the Vc of t as 10 volt. We will simplify this expression. Now it is 10 divided by 12 is equal to 1 minus e raised to the power of minus t by tau. This division is 0.883 is equal to 1 minus e raised to the power of minus t by tau. This value e raised to the power of minus t by tau is equal to 1 minus this value, which is 0.167. If we will take the log on both sides, in that particular case, t divided by 16 into 10 raised to the power of minus 3 is equal to minus 1.789. And finally, we are able to calculate its value at the time at which voltage across capacitor is 10 volt, that is t is equal to 28.62 millisecond, that is 10 raised to the power of minus 3 second. Similarly, we are interested in the calculation of expression for current flowing through the capacitor. Always I will use this formula, that is IC of t is equal to, or current flowing through the capacitor is equal to, in this case, C into dVc upon dt. That is, current flowing through the capacitor is C into dV by dt, which is equal to, here C is the capacitor, which is 2 millifarad, that is 2 into 10 raised to the power of minus 3. D by dt of this Vc of t, and Vc of t is nothing but 12 in bracket 1 minus e raised to the power of minus t divided by 16 into 10 raised to the power of minus 3. If we will differentiate this equation with respect to t, we are able to calculate its value of the IC of t. This IC of t is equal to, this is 2 into 10 raised to the power of minus 3, this value is 12, then the differentiation of this constant term is 0, and differentiation of this e raised to the power of minus t by tau is, this is minus, which is minus 1 upon tau into e raised to the power of minus t divided by 60 into 10 raised to the power of minus 3. And this minus into minus, this value will be the plus. That's it. And if we are finding the multiplication of this 2 into 10 to the power of minus 3, 12, and this 1 upon tau, this value, then finally we are able to find out its value of the IC of t, which is 0.4 into e raised to the power of minus t by tau. And finally, we are interested in the calculation of the voltage across resistor. This VR of t is equal to R into I of t. We will substitute the value of R and I of t, which we have calculated here, that is 0.4 into e raised to the power of minus t by tau, which is tau is 60 into 10 raised to the power of minus 3, and this value will be 12 into e raised to the power of minus t by 60 into 10 raised to the power of minus 3. This is about this problem.